You want to scale your RDS deployment past a few thousand users? Here's how to do it. Hey everybody! I've been wanting to produce this video series for a long time because it tackles one of the greatest misconceptions about Microsoft Remote Desktop Services, namely that it can't scale to tens of thousands of users. So if you're an organization with 10,000 plus employees, or you're an ISV delivering your app to your customers over RDS with thousands of users, you'll have to switch to a much more expensive solution like Citrix or AVD if you have any hope of scaling your remoting platform. This couldn't be further from the truth. You can scale up your RDS environment so that it can handle 5,000, 10,000, 20,000, or even more users. I know this is true because I've both consulted with and sold our software to companies with RDS user bases in excess of 20,000 users. They all experience some growing pains and choke points when scaling up, so the purpose of this video is to educate you in advance so you'll be ready when your RDS deployment grows larger and larger over time. And as a bonus, many of these tips are useful in RDS deployments of all sizes and will directly improve the responsiveness of your connection brokers and the overall stability of your RDS environment. Let's first go back in time a bit and watch an older Microsoft Mechanics video where Scott Manchester, who's now the product group leader for Windows 365 and AVD, talk about this great work they've done optimizing the RDS connection broker in Windows Server 2016. He talks about how they built a nifty tool for stress testing the connection broker for login storms, where up to 1,000 users sign in at the same time. He even says they've been testing it up to 10,000 users. Typical Microsoft rah-rah hype, of course, but as we know in life, the devil's in the details.
Yeah, that was another major investment area for us with 2016. Our primary investment was around our connection broker. So what we see in some deployments are what we call login storms, where you get this 9 a.m. Monday morning scenario where everybody's trying to connect at the same time. And that really taxes our connection broker and can cause delays in people being able to connect. So what we've done is really focused in investments on our connection broker, and we've built out this simulation tool that can really test the scalability of it and push it to its limits. So here on my screen you can see we're just getting ready to launch this test case. And in this particular test case we've set up 1,000 users and 100 session host servers. So let's go ahead and start the simulation here. So here we're actually a couple minutes into the simulation, and what I want to show you is we've made at this point in time, let's see, about 520 connections. So you can see 520 connections and 0 failures. So let's jump to the end and see how well this thing performed. So here at the end, you can see our summary that we had 1,000 connections with 0 failures. Now this was not the kind of results we used to see in previous releases of our connection broker, and really enables users to deploy much larger systems.
And that's well beyond the majority of real-world use cases anyway.
Yeah, and we've tested this to some extreme boundaries. Like we've run test cases with up to 10,000 users trying to connect, and a variety of different number of session host servers as well.
In the real world, beyond Scott's little stress testing script, the connection broker doesn't fare as well dealing with large user bases when running with its default settings. Why? The first reason relates to the connection broker's dependency on Microsoft SQL Server. RDS connection brokers use SQL Server to maintain an inventory of how users are load balanced across the session host in RDS collections, and which host each user is assigned to in case of a disconnection and reconnection. Small deployments with a single connection broker have an internal version of SQL, which is basically SQL Express, running on the same VM as the connection broker. Larger deployments, in an RDS high availability configuration, have a dedicated SQL Server cluster which all brokers consult with for information. Anyway, Microsoft architected RDS so that the brokers execute a bunch of stored procedures on the SQL Server to get the information they need when a user's trying to initially connect or reconnect to the environment. Unfortunately, as some of my larger customers have discovered, when connection brokers start getting lots of login requests during morning or after lunch login storms, tons of those stored procedures get executed at the same time. Those connection storms often cause deadlocks on the SQL server, which can result in your brokers going off into la-la land, your users being unable to connect, connections taking a really long time to complete, etc. So the question becomes, how can we tune SQL to make it not run home to mama when the connection brokers are calling thousands of stored procedures at the same time? The answer is, increase the cost threshold for parallelism default value on your SQL server from 5 to 25. Now, I'm not going to get into the underlying mechanics of how and why this can benefit the situation, which is better left to hardcore SQL nerds like Brent Ozar if you want to read his blog article. Adjusting the default value of 5 up to 25 was the magic change that I saw recommended for Microsoft support during a consulting engagement, but your environment may need a smaller or larger number. As with all things, test this first before rolling it out into production, and be prepared to revert the value if performance worsens instead of improves. But in every environment I've ever consulted in, moving this value from 5 to 25 has helped substantially as opposed to hurting scalability. By the way, if you're running RDS in Azure and you have your HA connection brokers communicating with Azure SQL, you can experiment with increasing the max DOP value, which stands for max degree of parallelism. At a minimum, take a look at this value because if your deployment is older, your Azure SQL database may have a default value of 1, which means a single serial thread will be executing queries. Newer Azure SQL deployments have a default max DOP value of 8. Let's now move on and talk about another major choke point for scalability with the connection broker. That choke point revolves around WMI handle count limits. Lots of folks with RDS deployments don't know this, but WMI is the glue that holds many of the RDS infrastructure roles together, and various infra roles like the broker and RDWeb issue lots of WMI queries back and forth while operating. The larger the user base of the farm, the more WMI queries get issued. Since the connection brokers are the brains of the farm, so to speak, they handle the majority of WMI queries, and Windows imposes a hard quota limit on WMI handles, where 4096 is the default. If a server VM running a connection broker goes over that limit, the WMI provider service will crash, and then you can end up with a cascading failure on a connection broker. Alas, adding more HA connection brokers to your deployment is not the fix, because in many cases WMI queries still get issued to a single connection broker in the group, which acts as primary for those WMI requests, even though any connection broker in the group can field incoming RDP connection requests as passed on from a load balancer. You'll know if this is happening because you'll get event ID 5612 in the application event log from the WMI provider service indicating a crash of that service. Fortunately, you can increase the default WMI handle count on your brokers from 4096 to 8192 to combat WMI handle exhaustion on those brokers, which will let them serve a greater number of concurrent users without problems. To do this, you'll need to launch the little-known WBEM test utility on each of your brokers. Watch each step in this video to see how that's done. After making these two tweaks in your high availability RDS environment, your brokers should be able to handle a substantially larger volume of users during login storm bursts and higher sustained numbers of peak users when lots of concurrent users are connected. Stay tuned for my next videos in this series where I will talk about properly load balancing gateway servers, the concept of clustering multiple smaller RDS deployments together instead of attempting to build a single large deployment, and how to effectively manage larger RDS environments. Hi there. If you'd like me to make more of this content, please do one of the following. First, Like this video and click the notification bell below to subscribe to the RDP Hard channel. Second, download my company's free Remote Desktop Commander Lite tool to help you manage sessions on your RDS and AVD farms. It's more powerful and much faster than the built-in RDS Manager. Third, consider purchasing my RDP Own book on how to secure your RDS environments. It's only $9.99 on Amazon Kindle. Fourth, start a subscription to one or more of my company's commercial RDS and AVD monitoring and management tools. We offer very affordable monthly subscriptions you can use for as little or as long as you need. I think you'll find we deliver more value than just about any other RDS monitoring tool in the marketplace. Thank you. See you on my next video.